Hello again. Let's talk about the Arduino software UART written in assembler. I think you have seen part 1 and now we will go into the depths. The second UART is used for debugging purposes. The design goals are: it should be fast. It should receive the characters via interrupt. It should be usable with streams, which means you can use printf statements. And I don't want to use a timer. Maybe they are used for other purposes. I want to use the second serial port for debugging, because most of my programs are using the first serial port to communicate with the computer. Let us take a look at the Arduino sketch. This is the interrupt service routine. Here we see the fastest way to react on an interrupt. In the interrupt service routine, I have written ISR naked. That means no prologue and no epilogue is built by the compiler. And with the assembler statement jump receive byte, we have just one instruction from interrupt to our assembler source. Now let's look at the assembler source. The ports and bits are defined with a define statement and not saved in a variable, because this is much faster. Okay, I have a send port and a send bit, that is port B, and send bit is bit 1, and I have a receive port, that is pin D with the receive bit 2. And I have a signal port and a signal bit. At the signal bit I produce very small peaks to see at the scope where at the time slice of a bit I just collect the data. In the interrupt service routine, I have to write my own prologue, where I have to save the registers I will use in this routine, and I have to save the state of the processor. The heart of the routine is the part where I receive the single bits of a byte. Well, it's really simple. In register 17, I load the number 8 for 8 bits. Then I loop. At first, I will build the signal peak, then I decide if I have to set a carry or not, which I will rotate. And then I call the delay 1. Delay 1 is a very sophisticated routine to build the delay for all the different baud rates I will use. I have to comment out one of them, set bit clear bit, which builds the small peak, or the del 4 delay 4, which does for no ops, just to consume 4 cycles. Let us look at the live game again. The live game is running inside the Arduino, and the computed values are transferred via our software UART to the computer, who displays the values on the screen. We start with a transfer rate of 9600 baud. As we can see, this baud rate is far too slow to do a real-time debugging. Now we will change the baud rate to 460,800, which means it's about 50 times faster. Now I will then switch to high speed in the source. This is so much faster that the Arduino is working at full speed now. It's a big difference. Well, together with the possibilities of the NZ terminal to place the cursor at different locations for writing out our debugging messages in different colors, will help us to do a real-time debugging now. The Arduino can do its time-critical work and can inform us about the state of the program. We can stop the program with a keystroke, and then we can see what has happened until now. Or we can define the conditions when the Arduino has to stop outside of time-critical sections and inform us about the internal state of the program. If you are interested in the sources, you will get them for free. Well, it's a beer license. what means if you use it and we will meet someday, you have to invite me for a beer. I think that's okay, isn't it? Just drop me a line to get the source. Well, it's free, but I want to know who is using it, and maybe we can talk about improvements of the source. Okay, thank you. My email address is info@helmutweber.de.